Alright, actually, let me pull this up and give you guys a hint. Let's say I wanted to draw another square, but I wanted to rotate it. Not that you'd ever have to do that. Okay? This is how easy this is. When I draw this angle, that's the 45, right? So actually, if I were to draw my square at the station point, it would look like this. One line would be going straight up to the vanishing point, and one line would be going straight sideways, and it would never hit the eye level. It's one-point perspective. So let's say I wanted to draw another square. Well, let's say I wanted to draw it here, and I wanted to rotate it. I can do it like this. Everyone watch closely because you're not going to believe it's this easy.
Wait, what?
I'm looking straight down on the real angle. So if I want to draw a square that's evenly split, I draw the vanishing points like that. One here and one here. If I want to draw it at a weird angle, where I'm only seeing a little bit of this side, I draw it like that. And I have a vanishing point here and a vanishing point going off to Milpitas.
It's crazy.
That's so cool.
And if I want to draw it another way, so I could do it like this. Let me just pick, I'm picking an angle randomly. I want to keep it on the page, but I'm going to pick an angle randomly. Now watch what happens. I can see some confusion. Watch what happens. Okay. Now if I pick, actually, well, I need to show you one additional thing, because what's missing here? We don't have a diagonal vanishing point. So I'd have to add that too. And I can add it like this. I have to do a couple weird things here. Okay. Now if I draw a diagonal to that point from my X, and I pick anywhere I want, like say there, to say that's one side, and if I draw to the vanishing point over here until I hit the diagonal, and then I draw back using the other vanishing point, that's a square rotated. Now mind you, it's not necessarily the same size or anything like that. Okay, well, does that make sense now? Kind of, sort of. We'll be doing this multiple times. Okay, yeah.
How did you get the second diagonal vanishing?
What I did was, let me show you. Hang on. Brandon, add a note. I need some colored markers. Okay. So watch carefully because I don't have the colored markers. But, okay, when I establish these two vanishing points, these are established with an actual 90. Now look in between. That's an actual 45 off that 90. Because again, at the station point, all the angles are true. So in the same way that I created that first square with a 45, I do the same thing with the second square. It's just I've got multiple vanishing points. I'm okay. It's okay. I'll get them next. I've got some in my office. I just need to throw them in my bag. So you guys, this looks pretty messy, but does it make sense?
Kinda.
Split it to get
What was that?
You split it.
Yeah, I split it because the squares a split. You know, if I had some weird shape, I could use other angles. I don't have to use the 45, but the 45 gives me this square diagonal. Does that make more sense, Leslie? Okay. Oh, you guys, one other thing I want to emphasize this, because this is the first time we've done a drawing like this. I can usually tell when people are not getting it, because I see this. This is what it looks like, you guys, and I don't know why this happens, but it happens every class. They go like this. People go... You know, and I call it the prairie dog look because they'll be, and it's like a body language thing somehow. I will understand more if I am taller. You know? It's like, no, you won't.
It helps the information filter through in the
Yeah,
public.
yeah, it helps the information filter down. Yeah, yeah.
Can you re-explain the diagonal vanishing point, how you got that? Because it was just cutting 45.
Yeah, basically, the key is here. All squares, if you draw the diagonal of any square, it's always going to be a 45-degree angle. Okay. So what I have is, for my second cube, there's a vanishing point and here's a vanishing point. Okay, keep your eyes up for a sec. So I've got that actual angle. If I split it with an actual 45, I get the diagonal vanishing point for the second square.
Oh, okay, so it's,
Yeah.
if I use
Yeah. Please.
it's the two vanishing points split in half, which is always 45.
Yeah. Well, I mean, in the case of a square.
Yeah.
In the case of a square. Yeah. All right. So hopefully that makes sense. Because now I'm going to show you some even cooler things. All right. This one, I love this one because this one kind of blows people's minds. You can go different directions with this. Okay? I just proved to you that something was a square, right? Okay? Well, let's say I did it like this. Oh, by the way, you guys, this is why I got these. I had you guys get these. They're really cool. You can just go like this and go. And draw quick parallel lines. All right. That's a square. Is it? Yeah, if I say it is. Okay, so I don't have to find limit. I don't have to start with the station point to do this. I can just draw it and say, yeah, that's a square. Now, what if I draw it really weird? Can it still be a square? Yes, it can still be a square, but it will mean I'm getting some distortion of some kind. I'm out of the cone of vision or something weird going on like that. So you do need to be mindful, okay? But it can be. I can tell you it is. Now, I'm going to show you guys one of the coolest tools you have never used. I can say this because my family has some Polish heritage. This is a Polish compass. It's actually called a pair of dividers.